This is ICS235, and in this video I'm going to go over logistic regression. So let me get myself out of the way here, and I guess I can close this. All right, so we've seen linear regression predicts an output as a linear function of one or more of the input features. In the example of Adelaide penguins, for example, we have bill length and bill depth, and we could use for a numerical output example, a linear regression example, we can predict, for example, bill depth from bill length, and there's a equation which represents that, and the input is the bill length, and the output is a numerical value, which is the bill depth. We could also look at a categorical example. Here, let's go through this animation here. A linear model for regression looks at, for example, bill length and bill depth. A linear model predicting, this is not looking right. It's not coming out. So, okay, here we go. That looks a lot better. Let me make this a little bigger. So for a linear model would look at, predict bill depth from bill length. Equation looks like this. X is length, Y is depth. And but for classification, okay, for categorical data, let's say we're going to look at bill length, and we want to predict whether what we're looking at is an Adelaide penguin or not. Okay, so we look at a bunch of data, and we have a bunch of data where we have a bunch of Adelaide penguins up here on top, where we found a bunch of we have a bunch of penguins with a bunch of these different varying bill lengths, and all of these were Adelaide penguins. There were a bunch more that were not Adelaide penguins, and these were their bill length. So we created a linear model to predict if it's up here or down here, and the equation looks like this. But the problem is, when we try to use it, we don't get a 1 or a 0. We get something else. We get some number that's not meaningful for what we're trying to use it for. And another example here, you can go through this. This is predicting Gin2 penguins. Notice the bill length down here goes from 33 all the way up to 55. Here we're only looking up to, here we're only looking up to 44 or 46. That's the top of the Adelaide penguins bill length. Here we're looking at much longer bill lengths. It turns out that if we're looking at Gin2 penguins and we look at their bill length, it would look more like this. Again, we have the same problem where the equation is not giving us, yes, it's Gin2. No, it's not. No, it's not Gin2. It's giving us some number. And so what logistical regression does is it takes this linear function here, and it turns it into a prediction of the odds that the instance is the category that we're looking for or not. Okay, so we do this by this is the original equation right here for the linear function. These things up here, but here, instead of that giving us a y value, what it's going to give us is this logarithmic value, the natural log of this this fraction here, which on the top is the probability that something is what we're looking for, and below it, 1 minus that probability would be the probability that's not that. So if we're looking for Adelaide, is this Adelaide? Yeah, if we're looking at Adelaide penguins, a probability of 1 would be that it's an Adelaide penguin. A probability of 0 that it's not. Okay, so now this is algebra, and you don't need to know exactly how to manipulate this. Just believe that it's true, that if we solve for p, we get this equation here. And this exp, this here, that's actually notation for e to the x here. So this is actually e to the quantity w0 plus w1 times x over 1 plus e to the quantity w0 plus w1x. So, and that, lo and behold, because of logarithms and so on, gives us a model for classifying based on inputs. So we can go through this animation here, and we see that if this is the equation, x for x, this is x, and this is a probability between 0 and 1, then depending on what the bill length is, we get calculated out, we get a probability, which is right here, and it equals this value. And so 73% chance that it's an Adelaide penguin, and the probability that's not an Adelaide penguin is 26%. See, so that's 1 minus this. And so I'd like to just show you this calculation just so you can get a sense of what this is. You'll never have to do it, but if I open up the calculator, CALC, I'm going to do this. Calculator, I'm going to scientific calculator. Does it have my old calculations here? Let's see. No, it doesn't. Okay, so I'm going to use this is the Windows calculator. And the keys that we're going to use is we're going to use the E key, because that's actually this e to this thing here. We're going to use the E representation. And then we're going to use parentheses because this is actually e to the whatever inside here. So we're going to take advantage of that. And let's do this particular calculation here. So what this is E, it is, where's E? E, and then that's the X, and so we're going to use this X to the Y key. So E to the, and now we're going to put in Y, and Y is going to be parentheses. Let's move this over a little bit. Parentheses. I've hit the parentheses key already, you see right there. 50.24 minus, let's see it right there. 1 point, I have to do parentheses because I want to do the multiplication before I do the minus. So I put parentheses again. Parentheses 1.172 times 42, close the parentheses, and this number is 1.172 times 42. That's that number. And now we're going to do now we're going to close the parentheses to complete this 50.24 minus this number. So let's close the parentheses, and that's what this is. The Y, this is the, it's e to the X. So this is the X. This thing here is that, And then now we have in there 2 to this power. You see, this is represented here 2, and this caret means to the power of 50.24 minus 1.172 times 42. I don't know if you can see that. But anyway, so I can just hit the equal sign here now, and boom, that is the numerator, this whole numerator. This is e to the 50.24 minus 1.172 times 42 power. Okay, now I also use that down here, so I'm going to save this in the memory of the calculator. I'm going to say memory plus. Memory plus. So that's going to store it in the memory of the calculator. And then I'm going to do this number, that's what's in there now, divided by the denominator. So it's that number divided by the denominator. The denominator is going to be parentheses 1 plus what's in the memory. So I'm going to do recall memory. And then I'm going to 1 plus that, and I'm going to close the parentheses. And so this is the denominator now is in there. And now I'm going to do the division. Yeah, that's the denominator. And now I'm going to actually do the division, equal sign. Boom. And this is 0.734. That's what this is, 0.734. Okay, so I showed you how we did this calculation here. Never have to do it again. I don't think. There might be some time you do. But okay, so I've shown you that. So let's, if we, go through these participation activities, we can see some, understand these graphs, and the curve looks similar to this, and so there's this range here where we aren't super sure, but basically this shows what this is telling you here. If you go through this, what this is saying is if the probability is greater than 50%, then it's a 1, then it is in the category. If it's less than 50%, then it's not in the category. There's this classification threshold. All right, see, T.5 is usually the... Okay, so we can do multiple inputs, and that just means the equation here is bigger. We still have a single constant, the intercept, but the coefficients, there's going to be a coefficient for each input. So coefficient 1, coefficient 2, coefficient 3, and so on for each input. But it's the same kind of equation. It's e to that whole thing, blah, blah. All right. And so here we're using 2 inputs, the bill length and the bill depth, to figure out if it's an Adelaide penguin or not. Okay, so it's this bigger expression, or bigger exponent, e to this big thing over 1 plus e to this big thing. And so it looks like we get better, more closer to 1 or closer to 0 results. So this is for the Gen 2 penguin. All right, so let's do this. Let's do the see what we need to do for the lab. We're going to use this logistic regression model, and with that, with the model, we're also going to get this, what the intercept is, and that's where it crosses the y-axis, and this is the coefficient, the coefficient of the weight. So we're going to, for only one, I think it ends up being an array. This ends up being an array if there's more than one. All right, so now there is these 2 parameters. There's a penalty parameter, and this is penalty parameters. This is L. This is an L. L2 or L1 or none. L2, L1, or none. Okay, that's not a 1, it's an L. And then maximum iteration, these things, what this does is it goes through a bunch of iterations trying different values for the coefficients. And and the W0 and the W1, W2, W3. It just tries different iterations until the error rate drops to zero or close to zero. Okay, so we're going to use this logistic regression, this Jupyter example here. So I'm going to start it up, and meanwhile I'm going to get rid of this and open up here's the lab. And so let's once we open this up, so the first thing we're going to do is we're going to create a binary feature. Well, okay, first of all, we need to, let's go down here. It helps us out. First of all, we need to import the necessary libraries, and those would be, we need to import these two things, of course. We always need to do that. I'm going to copy, Control C, Control, there we go, Control V. And then we got to grab out, create a data frame. Wait, we also need to do this thing, this linear model, logistic regression. Copy, paste. Okay. And then we're going to do the, creating the data frame from the CSV file. That's same as this. We don't need to drop any instances because we have, what are we doing here? We're doing, NBA games. Based on, what this is going to end up being is, based on this value, we want to know whether or not, we want to predict, if this, can predict whether the team wins or loses. If we look at the data here, let's look at one of these files. We have points, this ELO underscore win, win, whatever that is, and game result. Okay, so it's this is the ELOI thing that we're going to look at, and then it's going to predict whether they lost the game or won the game. Okay, so that's what the data looks like. All the data is here. So when we go back here and we copy something looks like this, we don't need to drop any instances with missing values because there aren't going to be any missing values. So basically it's just NBA equals PD dot read underscore CSV parentheses quote whatever the file is. Let's start out just by doing this file because they give us the results, the test results for this file. So to start out, we're just going to use this file, and then when we actually run it to submit it to get our points, then we will actually use this this other file. Where is it? This one. This is the one we actually want to do, get the results for. Use that CSV file when we submit it. But for test purposes, we're going to use a smaller one. There's only 100 instances in this smaller one. So I'm going to put that here, this smaller one here for now. Oops, what the heck's the, okay, copy, paste. All right. So that does that makes the data frame. And then, now we got to do this thing, okay? Create a binary feature for game result where zero means lose, 0 means L, and 1 means W. So we're going to use a method that's it's a it is a scikit method. Is that right? let's see. Well, I'm just going to type it in here, and it is. It's a replace function. It's a replace function. So really, we're creating a new column, win. We don't have a column named win. We're going to create a new column off of game result. And so it's going to be NBA game result that, but we're going to use this replace method, replace, and when we do the replace method, we're going to replace in game result, we want to do the from and then the to. So we want to do, and in Python, you can do more than one at a time. There's some interesting things you can do in Python that way but we'll get to that later. But anyway, we're going to make, we're going to have an array here. We're going to make an L. L is going to change into something, and W is going to change into something. Okay, that's the from, and then there's the to, and the to is going to be we want integer 0, so let's do I, and I think they want us to do it this way: integer of 0, and then the W is going to convert into integer of 1. Okay. So I don't need this. Okay, so this is going to make a new column in the data frame where I think this must be a pandas thing. So where we take what this column is it's this column replacing L with 0 and replacing W with 1. Okay, that's what this does. All right, so that creates a binary feature. That creates a binary feature called win for game result, resulting in this. Okay, next we're going to use the logistic regression function with the penalty of L2 to construct a logistic regression model with win as its target. That's the Y. And ELO underscore I as the predictor. That's the X. And then we're going to fit it. We're going to fit it, and then we're going to just print out the weights. And then this prints out this proportion of scores correctly satisfied that they give you that. That's this thing down here. So here I have to initialize the model. So I'm going to do that just like first I'm going to create the inputs and the outputs. Okay, here we create the inputs and outputs first. So let's do that first. X is X equals. I'm going to get rid of that thing. X equals NBA of, and I got to do 2 double brackets, of NBA of ELO underscore, it's lowercase. Okay, that's what X is. And Y is lowercase. Y is NBA win. Just like that. That's X and Y. And then I got to initialize the model, and I'm going to call it model. Model equals logistic regression with the penalty equals L2. Oops, is that got to be in a quote? Yeah, this L2. Okay, L2. That's it. And then I'm going to say then I'm going to fit the model. Let's fit this thing. Model fit, that'll work. And it's going to be fit with X. And just in case No, doesn't hurt though. I don't think this hurts. Rabble of Y. For some reason, it's sometimes you don't have to do that. In fact, you might not have to do that this time, but anyway. Okay, that's it. That, and then now we're gonna print. That's the fitting. Where are we? Am I doing all this right? Yeah, fit construction witness target. Oh, anyway, okay. So, and then the weights are, we're gonna print them. So W1 is the coefficient. So that's model.coef underscore. And W0 is the intercept, where it intersects the y-axis. Model intercept underscore. And then this, let's see what the score is. Score is model score X. And this time, for some reason, I guess you have to put Rabble. All right. So, if it doesn't work, then put Rabble. Okay. Anyway, let's. Okay. So this is we're doing the small data. So let's just run this, see what happens. Oh, whoa, no errors. That looks 3.64, 2.802. Yeah, it looks right. It looks the same. And so I guess what we do now is we change this to log. Yeah. And then you would running it, and that looks different. That looks like 59. So that looks like that's better at predicting. Oh no, it looks like it did better with the larger sample. Okay, anyway, so then you can click submit for grading, and that should give it to you. All right, so I've covered logistic regression as well as I can. I think it's better for you to read the chapter because sometimes I get mixed up in my terminology. I don't know when, but sometimes I do. Anyway, so I hope this helps, and thanks for watching. See you next time.